And today we are looking at unit number 2 of energy and change. Remember term 3 we are doing energy and change, and we are looking at unit number 2 on page 173. And unit number 2 covers energy transfer in electrical systems. Energy transfer in electrical systems. And this unit is divided into 3 sections, which is current, electricity, components of electrical circuits, and effects of electrical current. Okay, and if you can see, 2.2 is divided into 4 sections, and 2.3 is divided also into 3 sections. So let's start with the current, electricity. In the previous unit, which was static electricity, we saw that electrons can move. Current electricity consists of many electrons that continuously move in a circuit. It is difficult to count the electrons individually. Therefore, electrons are grouped or quantified. This group of electrons are called coulomb. Okay, the unit in which the charge is measured is coulomb, which is 1C. Okay, and 1 coulomb is about 6.25 times 10 to the power 18 electrons. That is a lot of electrons. It's about a million. It's 10 to the power 6. I don't even know, but it's a very big number. So 1 coulomb has got 6.25 times 10 to the power 18 electrons. Now let's get the definition of current electricity. Current electricity is the continuous flow of charge. Current electricity is the continuous flow of charge. You need to know this definition. When coulomb is written in full, it is with a small letter. If it is abbreviated, it is a capital letter. So abbreviated is C in capital letter, and when we write it in full, the C is small to say coulomb. Electrical current transfers energy. That is why a light bulb can glow. It glows because there is energy transfer. Electrical current that flows in a circuit is called current electricity, and we know current electricity is a continuous flow of charge. The following is required for the current to flow. So these 3 things must happen for current to flow. We must have a source of electrical energy, the circuit must be closed, and we must have conductors in a circuit. A source of electrical energy, a closed circuit, and conductors in a circuit. Very important to know the 3 things that we need for current to flow in page 173. At the top of page 174, a circuit is a complete or closed conduction path for electricity. The components must be attached to each other from one terminal of the cell or battery. Okay, this is the terminal, this is another terminal. Along wires or conductors. Okay, let's start and read. The components must be attached on each other from one terminal of the cell or battery, along wires or conductors, through the filament of the incandescent bulbs or other components, and back to the other terminal of the cell or battery. Don't worry, you'll see this when we look at the circuits. Now let's look at the components of an electrical circuit. There are various components of an electrical circuit. They say study the table below of a circuit components and their symbols. Okay, so let's look at this. You have done this from grade 6 or grade 5 for that matter. The name of the component, this is a connector or a conductor. The symbol is just a black solid line. This is a cell. We normally call this a battery. Please, if it's only one, don't call it a battery, it is a cell. This is the symbol, long stick, a short stick. Okay, and then we have a battery. It's two or more cells connected, and we have an open switch. You see it is open. This is how we represent it. We have a closed switch. That's a closed switch symbol. We have a resistor. This is a resistor. That's a symbol for resistor. And we have the light bulb. Okay, and this is the symbol for the light bulb. We have the ammeter. Ammeter, you see it has got an A to tell you it's an ammeter. Ammeter. Okay, voltmeter, we've got a V to tell you it is a voltmeter. These are the components of the electrical circuit. Please know them, know their names, know their component, and know their symbol. If these components are connected to each other to form a closed circuit, electrical current will flow and the light bulb will glow. The minimum components in a circuit are a source of energy, conductors, and something to give them an indication that a current is flowing, for example, a bulb or ammeter. Let's look at the connecting wires. Connecting wires are made from metals that are good conductors, like for example copper. It transfers electrical charge over a short or long distance. And let's look at the battery. A battery is a combination of more than one cell connected in series. Okay, that is a battery. A cell or a battery is the source of electrical energy. Remember, we said one of the three things we need for current to flow, it is the energy source. Cells have a chemical substance inside it that store chemical potential energy. These chemicals react only when the circuit is complete. The battery or cell uses the chemical reaction. It converts chemical energy into electrical energy. Now you know how batteries works. They convert chemical energy to electrical energy. The electrical energy is delivered to the circuit. They say the battery of a motor car consists of 3 or 6 cells. Okay. The cell creates a potential difference, which is the tension, by supplying an electrical kinetic energy to electrical charges, which is electrons. These charges then flow through the connectors. The chemical potential energy in the cell is converted to electrical kinetic energy in the charges that flow. There are various sizes and shapes of cells. You see, we have different of them. Types of cells differ from AAA, AAA or AA, C, D, up to 9-volt sizes. What should I do with old cells that are flat? Cells, except for rechargeable cells, cannot be recycled economically. However, the cells cannot be simply thrown away with normal household rubbish because it contains harmful poisonous chemicals that can end up in the soil and run off water. Find out where old cells can be recycled safely in your environment. Potential energy is stored in the cell by chemical materials. Now we look at the switch. A switch is used to open or close a circuit. It is an easy way to control the flow in circuits. Switches are used in flashlights, radios, and TVs. Switches are used as a safety measures by providing a convenient way of controlling electrical energy. Electrical energy system safely when high voltages are used. A circuit is open when you open the switch or remove one of the connecting wires. When the electric path is complete, we call it a closed circuit. In closed circuit, the current flows and the bulb glows. When there is a break in the electric path, we have an open or incomplete circuit. No current flows and the bulb will not glow in an open circuit. Reason for an incomplete circuit could be open switch, a loose contact at the switch, so it's not touching fully, a loose connection, a broken wire, or a broken filament in the light bulb. Okay, when the switch is open, the circuit is not, when the switch is open, the circuit is incomplete and no current will flow. The bulb does not glow. So the switch is open, the circuit is incomplete. This will be dark. If the switch is closed, the circuit is complete and the current will flow and this bulb will glow. Okay. And they say draw diagrams of the following. Is drawing the circuit, this one. And then let's look at the resistors. Resistors are made from material that offers resistance against the flow of electrical current in a circuit. Resistors are therefore poor conductors. The resistors in a circuit have an effect on the magnitude of electrical current in the circuit. The higher the resistance, the weaker the current. A weaker current results in the bulb glowing more dimly. A resistor is a circuit component that offers resistance against the flow of charge. This is a definition, you need to know it. A resistor is a circuit component that offers resistance against the flow of charge. A resistor will heat up when it offers resistance against the flow of current. In some resistors, this heat energy can be very useful. Examples of heat energy being given off are elements in the kettle, heaters, geysers, and stoves. Okay. An old-fashioned light bulb contains a resistor wire known as a filament. That thing. Okay. The resistor wire connected to two contact points. One of the points is connected to the screw part and the other point is connected to the soldered knob at the bottom. The two contacts are separated by an insulator. Filament heats up until it is white hot when it is connected in the circuit. It converts the electrical energy to heat and light energy. And we get example of resistors, which is light bulbs, elements in the kettles, heaters, geysers, and stoves. Okay, those are the example of resistors. Okay, so with that said, you can be able to do exercise number 16. Exercise number 16 on page 178. Okay.